Problem 12, integer to Roman. So basically here, the question is we will get an integer and we have to convert it to a Roman numeral. And there are some explanations here how that is done. In fact, there is basically pretty much an algorithm how to do it. If the value does not start with 4 or 9 as a string, then select a symbol for the maximum value. But I think we can ignore the algorithm they've described here. We can probably do even better, maybe, or simpler. I don't know whether it's better or not, to be honest. So I will, you know what, I will try to do this in a editor that gives me slightly better type checking, etc., because this editor does not do a lot of checks as I type, so it's easier for me to do it in this TypeScript playground. So let's try to let's see what we can do here. Let's create constant Roman values. Yeah, so I'm just gonna copy these values over here, right? So just bear with me for a second. So that one here. Now just a few more seconds and we should be, oops, sorry, comma, oops. Okay, so we have these things here. That is fine. Now, they also very helpfully give us these forms that are written. These are the subtractive forms, right? So 4 is 1 minus 1 less than 5, and 9 is 1 less than 10, so it's 40, 10 less than 50, etc. So I'm just going to copy these as well to here. So you know what, I'll place them in the end, these subtractive forms. So that is 4, right? And then this is 9, and then XL is 40, correct? And then XC, that is 90, CD is 400, and CM is 900. Okay, so we have this constant, right? Roman values. Now, let's keep this unfolded for a second. Now, this is not a very good way of representing this information. So probably do Roman val. I probably should think of a better name. So object entries of Roman values. Now, if I do that, then it's string and number. Not great. I mean, technically this is fine, but normally we could probably create a type Roman digit, which would be key of value of Roman values, right? Type of. Okay, so our Roman digit is, well, these subtractive forms, I also turned them into digits, basically, as if they are a single digit, yeah? So they are a single digit in some sense, but they are comprised of 2 Roman digits. Now, I can say here as this is a tuple, so Roman digit and some Arabic number, right? And of course, this must be an array, right? So, but I want to convert this. Let's convert that map. So this is a two-dimensional array, or kind of an array of tuples. So I want to map this into, let's say, Roman and Arabic. And let's map them to Roman Arabic. So that is probably a slightly better, this is probably a slightly better form. So now this is basically an array of, things like that. So this is an array of something like Roman 1 and Arabic 1, and then Roman, let's say, 4 and Arabic 4. So it's something like that. Okay, it's something like this. Well, not something like this, it's precisely that form. And we probably need to sort this, right? So in order for us to sort this thing, basically we need to get the Arabic values as A1 and Arabic as A2. So A1 and A2 are Arabic values, so A1 minus A2. So we're going to sort them ascending with these keys, right? Arabic. Because here we don't have these things properly sorted. And now Roman val will be this sort of object, this array of objects like this, but sorted in ascending order by Arabic value, which is kind of the same in some sense that the Roman value. So this is sorted. Now what I'm going to do is, let's create so Roman value, right? So that's the Roman. This is going to be a string which will contain eventually the Roman literal, Roman number, numeral. Now we're going to do while our num is above 0. So num is this value here, right? So while num is, and eventually we're going to return Roman, right? To get rid of these squiggles. So eventually we're going to return this Roman. But we're going to keep converting parts of this num into Roman numerals. And what we're going to do is, now we have basically this sorted, so we can start and find the largest, start from the end and find the largest number that can be subtracted from num. So we could obviously do a binary search, but this is so small, this array, I just won't bother about it. Just not to make this code any more complex than it needs to be. So why don't I just say let index equal, so this is Roman val length minus 1. So the last element, pointing to the last element of the of this Roman val, which is kind of this sort of information in a slightly more useful way. Now, while what? While Roman val with this index is still bigger, strictly bigger than our num, we cannot subtract it. It's not usable, right? Oh, sorry. Num Arabic, right? So that's the Arabic value. So if the Roman i's Arabic value is strictly bigger than num, so for example, initially it's going to be 1000, then 900. If it's still bigger than num, then we can't subtract it. So we should do this, get to the next I, right? But when we are done with this, we will have precisely the index, which is which we can use. Now, just in case, just notice this while won't go into an infinite loop. So if we cannot find anything, then eventually JavaScript will return undefined here, and this will be an error. So we could avoid that in various ways, but let's not avoid it because this should not happen. This should not. We should pay attention to that sort of thing, but this will never happen. Especially in a program like this where we're not giving this to other developers to play with it or anything. So here we found the index. We found this index, which means our Roman should be added. So Roman val I Roman, right? But num should be subtracted with the same kind of value, but in Arabic format. And that should be our code. Yeah. So if I just take all of this, I mean, we could test it here, but I mean, let's just take it. Let's hope that we've actually written it properly and give ourselves benefit of doubt. Yeah, well, this kind of did all three pre-tests. Let's submit it. Keeping fingers crossed. Let's see what happens. Accepted. Not the fastest solution ever, which is probably understandable because we're not using binary search. Maybe that gives us a little bit of, well, anyway, it's very simple. This is the whole, I mean, this is the whole algorithm here. We could basically, this is the algorithm. And this you could just simply convert this into a slightly better format. So all of this can be just achieved by properly writing this instead of just copy pasting it directly from the problem description. Just copy pasted stuff here. Okay, I think this is fine.